Look, you think buying one of these depreciated Ford Powerstrokes means you're beating the system, but you're walking right into a trap that Ford engineered from the factory. I have spent over 15 years knee-deep in diesel grease, tearing down these exact engines, and I am here to tell you that your Super Duty is quietly killing itself while you drive it. The manufacturer didn't build these trucks to last 500,000 miles anymore. They built them to survive the warranty period and then gracefully exit the stage, so you have to buy a new one. Most owners have absolutely no idea that the factory software and default settings are actively sabotaging their powertrain every single day. Today, I am exposing 5 factory settings and features that are causing hidden damage, waste, and catastrophic inefficiency without you ever knowing it. Setting number 3 has caused more complete engine failures in my shop than almost anything else. And setting number 1 is so incredibly deceptive that most owners actually think it is beneficial to the truck when it is doing the exact opposite. Let's get into it. Setting number 5, the Factory Intelligent Oil Life Monitor. Ford proudly markets this feature as a high-tech system that tracks your driving habits, engine temperatures, and idle time to calculate exactly when you need an oil change. They tell you it's safe to stretch your oil drain intervals up to 10,000 miles or 12 months under normal operating conditions. But here's what Ford doesn't tell you. That algorithm is optimized for marketing brochures and fleet cost of ownership data, not for the tight mechanical clearances of a high-pressure common rail diesel engine. When you follow that factory oil life monitor, you are running your engine on heavily degraded fuel-diluted oil. In my shop, I have pulled oil samples from 6.7-liter Powerstrokes running at just 15% remaining oil life, according to the dash, and the laboratory analysis sheets tell a horrifying story. Because of the aggressive active regeneration cycles these trucks use to clear out the diesel particulate filter, raw diesel fuel gets sprayed into the cylinders on the exhaust stroke. A percentage of that raw fuel inevitably washes past the piston rings and enters the oil pan. By the time that factory monitor tells you it's time for a change, the oil viscosity has often dropped from a protective 15W40 down to a dangerously thin 5W30 or worse, combined with a fuel dilution percentage exceeding 4%. At that level of dilution, the oil film's strength completely collapses. Your engine bearings are literally starving for protection. The thin film of oil that is supposed to keep your crankshaft and rod bearings from touching the metal journals vanishes under heavy towing loads. You are effectively grinding your engine bearings to dust every time you hook up a trailer at the end of an extended oil cycle. The damage is completely invisible, cumulative, and silent until the day a rod bearing spins and throws a rod through the side of your block, sticking you with a $15,000 bill for a new long block. The solution to this factory trap is simple. Ignore the dashboard completely. Reset the monitor if you have to keep the light off, but draw a hard line in the sand at 5,000 miles or 6 months, whichever comes first. If you idle the truck heavily or use it for short trips where the engine never reaches full operating temperature, cut that down to 4,000 miles. Spending an extra $100 a year on high-quality motorcraft oil and filters is cheap insurance compared to letting a piece of corporate software dictate the lifespan of your crankshaft. Setting number 4 is one that Ford markets as a major less-saving benefit, but under everyday driving conditions, it is creating the exact environment that destroys your high-pressure fuel system. I am talking about the factory automatic transmission shift schedule on the 6R140 and 10R140 transmissions. Specifically, the aggressive torque converter lockup and low RPM upshift strategy. Ford programs these trucks to upshift into the highest gear possible, as fast as possible, to keep the engine lugging along at 100 to 1200 RPM, in the name of corporate average fuel economy. They want the engine turning as slowly as possible to save a fraction of a gallon of fuel. But when a massive 6.7-liter V8 diesel lugs at 1,100 RPM under load, the torsional vibrations traveling through the crankshaft are immense. More importantly, at that ultra-low RPM, the factory oil pump and the high-pressure fuel pump are spinning at their lowest relative speeds. which dramatically reduces internal lubrication pressures. Inside the Bosch CTP 4.2 high-pressure fuel pump found on these trucks, the internal lifters and rollers rely entirely on the lubricity of the incoming diesel fuel to glide smoothly over the pump's internal cam lobe. When you lug the engine under load at low RPM, the mechanical stress on that pump roller increases exponentially while the fuel flow volume cooling and lubricating the pump is at a minimum. The roller starts to slide instead of roll. It begins shaving microscopic pieces of metal off the cam lobe. Once that metal-on-metal wear begins, it's a ticking time bomb. The debris from the failing pump is sent directly down the fuel rails, ruining all 8 fuel injectors, the pressure regulators, and contaminating the entire fuel tank. If you miss the early warning signs of a hard start or a rough idle, the pump sends debris through the entire system, and you are looking at a complete fuel system replacement that regularly reaches $8,000 to $12,000 at an independent shop. To override this efficiency setting and protect your fuel system, you need to change how you drive the truck. Stop letting the transmission lug the engine in standard drive mode. When you are driving around town under 50 miles per hour, or whenever you are pulling a load, manually select tow haul mode or use the progressive shift control on the gear stalk to lock out the higher overdrive gears. Keep that engine spinning in its sweet spot between 1,600 and 1,900 RPM. This increases oil pressure, ensures maximum fuel volume is flowing through the CP4 pump to keep it cool, and eliminates the heavy torsional loading that causes premature wear on the fuel system components. We've already covered how Ford's software tricks you into running diluted oil and wearing out your high-pressure fuel pump just to chase a tiny bump in fuel economy. But the factory traps get significantly worse from here, and the next 2 settings are responsible for some of the most expensive component failures I see roll through my shop doors. Setting number 3. The factory exhaust gas recirculation temperature thresholds and actuation map. This is the setting that has caused more complete engine failures, cracked cylinder heads, and melted pistons in my shop than almost any other single factor on a Powerstroke engine. The exhaust gas recirculation system, or EGR, is designed to take highly concentrated, blistering hot exhaust gases from the exhaust manifold and dump them back into your engine's intake airstream to lower combustion temperatures and reduce nitrogen oxide emissions. To do this without melting your intake manifold, the exhaust gas has to pass through a liquid-to-air EGR cooler that is tied directly into your engine's primary cooling system. Here is what Ford doesn't tell you about how they programmed this system to operate. The factory actuation map is designed to maximize EGR flow under light load and cruise conditions to meet stringent federal emissions compliance structures, completely ignoring the thermal stress it puts on the back 2 cylinders of the engine. Ford's programming allows the EGR valve to command massive flow percentages even when the engine is under moderate acceleration or climbing a slight grade before the truck is fully warmed up. When you drive a truck with these factory settings, the constant cycling of raw 1200-degree exhaust gas through that cooler creates severe thermal shock. The factory software doesn't react fast enough to the massive spikes in exhaust gas temperature, causing the coolant inside the tiny passages of the EGR cooler to literally boil. When coolant boils, it undergoes localized vaporization, creating air pockets and skyrocketing internal pressures. Over time, this constant expansion and contraction causes the internal welds of the EGR cooler to fracture. Once that cooler cracks, the hidden mechanism turns lethal. Your engine begins drinking its own coolant. At first, it's just a tiny amount. You might notice the coolant reservoir dropping an inch every few weeks. But as that crack expands, raw coolant pours directly into the intake tract and enters cylinders number 7 and 8 at the back of the engine block. Because liquid cannot be compressed, you risk hydro-locking the engine. If it happens while you're driving down the highway at 65 miles per hour, the piston slams into a wall of liquid coolant, instantly bending the connecting rod, cracking the cylinder wall, and destroying the engine block beyond repair, even if it doesn't hydro-lock immediately. The burning coolant creates extreme localized heat zones that warp the cylinder head and blow the head gaskets right out of the engine. The solution to this factory engineering flaw is a complete shift in how you monitor and maintain the truck's cooling NG system. You cannot rely on the factory dashboard temperature gauge to tell you if the EGR system is failing, because that needle is programmed to stay dead center, anywhere between 180 and 230 degrees. You need to plug an electronic monitor into your OBD2 port and watch the live data for engine coolant temperature and oil temperature. If you see the spread between your engine oil and coolant temperature exceed 15 degrees Fahrenheit while driving at highway speeds, your oil cooler is plugging up, which directly starves the EGR cooler of vital coolant flow. Flush your cooling system every 50,000 miles using premium Motorcraft VC13G yellow coolant and distilled water. And replace the secondary cooling system thermostat early to ensure the system is shedding heat before the factory programming cooks the hardware. Setting number 2 is a feature that manufacturers market as a high-tech convenience that saves you time and protects your vehicle from theft. But behind the scenes, it is one of the quickest ways to choke your diesel engine to death. I am talking about the factory extended remote start and long idling calibration strategy. Ford built a beautiful system into your key fob and smartphone app that lets you start your Super Duty from the comfort of your kitchen table, letting it run for 10 to 15 minutes to warm up the cabin on a freezing winter morning or cool it down in the heat of summer. They even programmed an automatic idle shutdown feature that lets the truck sit there ticking away quietly. But here is the brutal mechanical reality of what happens inside a modern Powerstroke diesel engine when it sits at a low factory idle speed of around 650 to 700 RPM for extended periods. When a diesel engine idles at low RPM without a load, it does not generate enough internal combustion heat to maintain proper cylinder temperatures. Cylinder temperatures plunge below 400 degrees Fahrenheit. At that low temperature, the diesel fuel injected into the cylinder cannot burn completely. This causes a condition known in the diesel technician community as wet nesting. The unburnt fuel turns into a thick, sticky, carbon-rich soot that coats the inside of the combustion chamber, washes down the cylinder walls to dilute your oil, and glues the variable geometry vanes of your turbocharger in place. Worse yet, that heavy, unburnt soot travels directly out the exhaust valves and immediately hits your diesel particulate filter. Because the exhaust stream is cold, the DPF cannot burn the soot off naturally. It plugs up the microscopic ceramic channels of the filter at an alarming rate. The factory software sees this restriction and responds by forcing the truck into a high-heat active regeneration cycle the next time you drive, which uses massive amounts of raw fuel to cook the filter clean. This constant cycling cooks your exhaust valves, bakes your turbocharger bearings, and stresses every single emissions component on the truck. I have pulled apart variable geometry turbochargers on trucks with low mileage but high idle hours, and the internal actuator vanes were completely welded solid with carbon slag, requiring a complete $3,500 turbo replacement. To reverse the damage caused by this factory convenience setting, you must stop using the truck as a stationary generator or a preconditioned living room. If you use the remote start, limit it to no more than 2 or 3 minutes, just long enough to get oil pressure stable throughout the engine block. A diesel engine will never truly warm up sitting in a driveway. It needs a mechanical load to build heat. Get in the truck and drive it gently to bring it up to temperature. If you must leave the truck idling for extended periods due to job site requirements or extreme weather, you need to enable the high idle feature, also known as the stationary elevated idle control, through the factory upfitter switches. By wiring a simple resistor into the customer access wire bundle under the dash, you can flip a switch and command the engine to idle at 1200 to 1,500 RPM. This elevates cylinder temperatures, ensures complete combustion, eliminates wet nesting, and keeps the exhaust clean enough to save your expensive turbocharger and DPF from an early grave. We've exposed how factory strategies for oil monitoring, gear shifting, and idling are silently chipping away at your truck's lifespan. But all of those pale in comparison to number 1. This final factory feature is the ultimate deception, because Ford engineered it to give you absolute peace of mind while it actively hides a catastrophic failure right under your nose. Setting number 1. The factory dampened dashboard gauge strategy and false warning logic. This is the single most deceptive and harmful feature ever installed on a production diesel truck, and it is directly responsible for tens of thousands of bricked engines across the country. When you sit in the driver's seat of a late model Powerstroke, you look at a beautifully designed dashboard filled with gauges for your engine coolant temperature, oil pressure, and transmission temperature. You assume that if that needle is sitting comfortably in the middle of the normal range, your engine is completely healthy and operating at the perfect temperature. Ford explicitly markets this cluster as an advanced driver information center designed to keep you informed. But here is the terrifying truth about how these gauges actually function behind the glass. The dashboard gauges on your truck are not true, real-time instruments. They are glorified idiot lights disguised as sweeping needles. Ford utilizes a software logic loop that heavily dampens and normalizes the information coming from the actual engine sensors. They deliberately program the gauges to anchor themselves dead center in a buffered zone to prevent customers from driving to dealerships complaining about normal thermal fluctuations. For instance, the factory engine coolant temperature needle will stay perfectly straight and steady whether your engine is running at a safe 195 degrees Fahrenheit or a borderline melted 232 degrees. Think about the sheer insanity of that mechanism. By the time that needle finally moves out of the normal zone and flashes a red warning on your dash, the disaster has already happened. I have plugged diagnostic scanners into trucks coming into my shop on flatbeds, where the owner swears the temperature gauge never moved until the engine coughed and died. The live data loggers on the truck's computer showed the engine oil temperature had skyrocketed past 245 degrees 5 miles down the road, completely baking the liquid lubricity out of the oil and warping the cylinder heads. Because the factory gauge setting hid the warning until a catastrophic thermal threshold was crossed, the owner kept their foot on the accelerator, completely oblivious to the fact that they were cooking their engine bearings to slag. The same exact logic applies to your factory oil pressure gauge. It reads right in the middle, as long as the engine has a measly 5 to 7 pounds of pressure, which is barely enough to keep the engine spinning at idle, let alone protect the top-end valve train under heavy acceleration. This deceptive logic creates a false sense of security that leads directly to total mechanical ruin. You think you are monitoring your vehicle, but you are actually flying completely blind. The factory software is actively withholding the truth from you until the exact millisecond it is too late to do anything about it, transforming a minor fixable issue like a sticking thermostat or a small coolant leak into an absolute $18,000 engine replacement disaster. The solution to this ultimate factory trap is to completely bypass Ford's buffered dashboard and establish your own direct line of communication with the engine. You must install a dedicated aftermarket electronic monitor that reads raw, unfiltered data straight from the controller area network bus stream through your OBD2 port. Devices like an Edge Insight CTS3 or a Banks iDash are not performance tuners. They do not modify your vehicle's emissions or alter the engine computer, but they display the precise undampened numbers in real time. Set your own digital alerts on that aftermarket monitor. Program a warning to flash the moment your coolant temperature hits 222 degrees, or when your oil temperature climbs past 230 degrees. This gives you a critical 10 to 15 minute window to pull over, let the truck idle down, and diagnose a cooling issue before the factory software permits the engine to destroy itself. Understanding these 5 factory traps completely changes the game when it comes to owning or shopping for a used Ford Powerstroke. The manufacturer built these trucks to appeal to marketing committees, EPA regulators, and showroom buyers who want a completely silent, maintenance-free driving experience for the first 3 years of ownership. They did not build them for the guy who needs that truck to pull a 30-foot gooseneck trailer for the next 2 decades. If you leave your Super Duty completely stock and operate it strictly according to the factory default settings, you are letting Corporate cost-cutting measures dictate the expiration date of your powertrain. But when you arm yourself with precise mechanical data, shorten your oil change intervals to defeat fuel dilution, use your tow haul mode to keep your fuel system fully lubricated, stop long idling your engine to prevent carbon clogging, and monitor your true engine vitals through an aftermarket screen, you strip away every single vulnerability Ford engineered into these trucks. You turn a depreciated, heavily criticized truck into an absolute bulletproof powerhouse that will easily outrun and out-tow anything else on the highway for a fraction of the price of a brand new model. Take control of your maintenance, override the factory logic with smart driving habits, and never trust a dashboard needle to tell you the truth about what is happening inside your oil pan. If this deep dive gave you the exact actionable information you need to protect your truck and save thousands of dollars in unnecessary repairs, hit that subscribe button and turn on notifications. I drop real, unfiltered diesel technician insights every single week based on the broken trucks I am actually pulling apart right here in my shop. Drop a comment below right now and let me know which factory settings surprised you the most, or what your live engine temperatures are currently running on the highway. I read through every single comment to make sure you guys are getting the truth. Stay safe out there on the road, keep your engine temperatures in check, and I will see you in the next one.